We're all concerned about the environment these days. There's many forms of renewable energy available. They draw from solar, wind, water, geothermal. Hi, I'm Drew Taylor. I'm here today with Lynn Mueller, President and CEO of International Heat Exchange. He's going to talk a bit about a different form of renewable energy.
I've been in the sustainable energy business for 25 years. I had never thought that personally I would see the effects of climate change. Now I am. I thought the problem of climate change would be for my children or my grandchildren. Now I see villages on the north coast of North America, the ice is melting back, removing Eskimo villages. We are seeing high tides, we're seeing bizarre weather conditions. It is time to do something simple and effective. At International Wastewater Heat Exchange, we set out to find the perfect system to recover heat from sewage. So we looked at many systems that are available around the world, and we decided on the SHARC unit because it's simple, efficient, and can be applied to buildings from 100,000 square feet into the millions of square feet. When we first thought of the concept of using raw sewage as a heat source, we analyzed all the possible problems that could be contained within that sewage. Solids are one, fouling another, and just a general environment that you don't want to have to work in very often. So to make the SHARC unit effective, we had to make it reliable, affordable, and maintenance-free.
You know, the reality is our sewers have a vast amount of waste energy in them. Water comes into buildings at 7, 8, 9 degrees and leaves at somewhere between 20 and 25 degrees, and that's all energy that has been added to the water that goes into a project or into a building and then gets flushed away in the sewer system. But there's technology now in place that allows that kind of recovery at a building scale or at a neighborhood scale or at a larger community scale.
The SHARC sewage system is really adaptable to any building, hospitals, schools, community centers, district energy systems, any large building where you can get access to the sewage flow.
This technology is so flexible and its applications are so varied that it can apply in some really interesting situations. So from a municipality's perspective, they're charged with the responsibility of reducing their own municipal greenhouse gas levels. So they wonder, how are we going to achieve this? Well, waste heat recovery will do it in their recreation centers. It'll do it at their ice rinks. It'll do it in their pools. It'll do it in their city halls. So all of those applications are viable applications.
So 95% of the flow in a sewer system is water. That is approximately 20 degrees centigrade or 70 degrees Fahrenheit, which is a tremendous amount of energy stored. So the SHARC unit separates the solids from the water and gives you clean, usable, warm water as an energy source. That interfaces with your heat pump technology or chiller technology, and by means of refrigeration you can either move heat in and out of that water. So it provides you an endless source for heating, air conditioning, and domestic hot water at phenomenal efficiencies. When you use the sewage SHARC system for a cooling application, you have multiple benefits. It gives you a constant supply of even temperatured water for your cooling needs, but it also allows you to remove the cooling towers and that water usage from the cooling towers. The use of cooling towers requires evaporative water for their operation in the warmer temperatures, which requires a large amount of water being vaporized and put into the atmosphere. By using the sewer unit, you're merely moving that heat into the sewer system, avoiding heavy usage. In some cases, 80 to 100,000 gallons a day of water can be saved on an average 500,000 square foot building.
If you can create a medium that allows you to share energy effectively between a variety of different users, then you can generate a much stronger revenue model. And that's exactly what's essentially going on in heat recovery from the sewers. The sewer is bringing energy from someone else's residential precinct to another residential precinct. So we got waste here, we're recovering it here, and we're recycling that in a more effective manner.
If you were to consider the city of Vancouver, where they have approximately 1 million homes, every home drains one hot water tank full of water a day down the sewer. If you were to recover that energy alone from just domestic uses such as showering, dishes, etc., you could recover 50 billion BTUs a day just from that load. That amounts to 50,000 gigajoules of natural gas you wouldn't need to burn to heat that same amount of water. If you consider you've offset the use of 50,000 gigajoules of natural gas, our current rate is approximately $10 per gigajoule delivered to your house. That amounts to a savings every day of $500,000 a day. A good example of reductions in energy usage could be on an example we've recently done. The average energy bill was $1.5 million a year on natural gas. By recovering energy from the sewage system, that energy bill has been cut down to $680,000.
If you consider that the province's target of 2020 to reduce greenhouse emissions by 20%, well, this one technology in a residential, multifamily residential application will achieve far more than 20%.
I think we have a responsibility individually and as a community to meet these challenges, and even more so in the world we're heading towards.
I like to think that if you got up every morning and you knew you were putting $10 down the drain, if you thought that I could reach in there, get that $10 back out for you without getting your hands dirty, why wouldn't you do that?